This is Elise Castle again, and today I'm going to be covering how to generate a certificate for your domain. If you haven't had the chance, please check out my last video on installing Gen 3 locally on your laptop. I have one video for Minikube and one for Kind, so make sure to look at those before completing the steps outlined in this video. Alright, to start out with, please visit docs.gen3.org and look at this example deployment. Today we're going to be using certbot to complete the steps that I outline. So to start out with, we're just going to copy this first part, sudo certbot cert only manual, preferred challenge DNS. We're going to be verifying our domain with the DNS text record. So I'll just type that in. And then I'm going to paste in my host name here and just hit enter. All right. So now you can see I already have a certificate generated here, so I can either keep the existing one or renew. I'm going to just click renew. And then here you can see it prints out the text record that it wants me to create. So you just have to create a text record in wherever your domain is registered. For me, it's going to be in Route 53 in AWS. So I'm going to go and create this text record very quickly. Okay, after creating that text record, wait about 1 to 5 minutes and that should populate. Once you know it's populated, you can click enter here. All right, awesome. So here you can see where the certificate was generated and saved at. So we're going to want to put that in our values.yaml file. So this is the values file I used in the previous video. And for this, we're going to put it under the global section. So it's going to be under TLS and then cert. And we're going to be passing in a multi-line string here. So first, I'm going to copy the cert, which is this one, and just cat that file. Have to have sudo privileges for this. All right, now we'll copy that cert and paste that into our values file. And just double check the indentation on this. Looks like this is a little off, so I'm just going to adjust that. Then we're going to put in our private key. Just type in key. And then this is also a multi-line string. So I'm just going to copy this command. And then paste this into my values file as well. And just adjust that indentation again. And then we can run our helm install command again. All right, this will take a second to populate. All right, now that that's populated, you can see we no longer have that error here. So we're ready to move on to the next step. Before we're able to submit data to our Sheepdog service and access the Workspace tab, we first need to grant the mock auth user proper permissions. So if you remember in a previous video, we set mock auth equal to true in our values.yaml file. This makes it so when we visit our data commons, it automatically signs us in as user test. So in order to grant user test the proper permissions, we need to run the user YAML job. And this job is part of our fence service, which deals with authentication. So I'm going to go over to our Helm Charts and I'm going to find the fence service here and click on that. And then I'm going to go to the values.yaml file. And here I'm going to search for user_YAML. And you can see a bunch of YAML is defined here. And what this job basically will do is it will sync Arborist with the latest roles and policies that's defined here. Since we want to overwrite the default user YAML, I'm going to copy this whole user YAML section. Just going to find the end here and copy upwards. Then I'm going to go over to our values.yaml file and go under fence. And I'll make sure it's aligned with this fence config here. So I'm going to paste that, then I'll just highlight it all again and indent that properly. All right, now that we have that user YAML added, we can start editing and adding our test user. So first I'm going to start out in this groups section. You can see there's two default groups defined here, and groups basically just put together policies, and you can add various policies to one user via groups. So here I'm just going to add test and test, and then scroll down, you'll see resources. We're not actually going to edit this section, but I just wanted to point out this section right here. The programs resource, which defines the name of the program and the name of the project. For Gen 3, a program is going to be a higher level grouping of things, so something like cancer research, whereas a project is going to be more granular, so something like lung cancer study. So just keep this in mind for our next section when we're going to be submitting data to our first program and project. Then we can scroll down. We are going to need a workspace policy. Since this policy was not defined in any of the above groups, we are going to need to copy that. And we're going to scroll all the way down. There's some different roles defined here, but we don't need to edit anything here. And under users, we are going to add user test. And under user test, I'm going to just add policies, and I'm going to add that workspace policies, which is going to allow us to access that Workspace tab. If you'd like full documentation on how to configure the user YAML, please go to our Fence repository and find this user YAML guide that will walk you through more ways you can configure this YAML. But for now, we're just going to apply what we have, so I've saved that file. First and foremost, we're going to do a get jobs, and we're actually going to delete the job user YAML. So upon install, this user YAML job is automatically created and runs. And since we had the default YAML in there before and we're now overwriting it, we need to delete this job in order for it to repopulate. So I'm just going to delete that, and I'm going to run our Helm upgrade command again. Now if we do a git pods, we can see this job is now running again. And we can follow the logs and wait for this to complete. All right, now that our job has completed, we should have the proper permissions for our test user. So we're ready to move on to the next steps. Now we're ready to submit data to our Gen3 Data Commons. So you can see right here, there is nothing to load here because we don't have any data yet. And so in order to do that, we need to create data. We can use our data simulator image. But first and foremost, I just want to go to our Gen3 chart and point out the default data dictionary here. So if we scroll down under the global section, or we can search here for dictionary, here it is. We have this default dev data dictionary, which will work great with our data simulator image. This dictionary is basically just going to define the schema for any of the data we submit. So if you're looking to create your own data dictionary, please visit this gen3.org site and look under creating a new data dictionary after completing this tutorial. All right, I'm going to pop over to the data simulator repository. You can visit this repository to see some of the commands I'm going to run in this tutorial. But to start out with, I'm just going to hop over to my terminal and start out by running the data simulator image. So I'm doing this via docker run command. I'm adding this flag here so that I can add the elise.dev.planx.net domain to the containers etc host file and map that to my local IP address. And then here, this is just the container, and we're going to exec right into it. To start out with, we need to get authenticated, so I'm just going to create a file called token. And we can hop over to our data commons where we're already signed in. And here you can see I'm in this application tab. To get into this, you can just right click, inspect, and then go over to application, and then find your access token, copy that, and paste it into the file, and then save. From there, we're going to be creating a directory to put all of our test data in. So I'm just going to run the make directory command and call it sample test data. From here, I'm going to run that data simulator simulate command that you'll see in the repository. So this is what's actually going to generate that data. Here you can see I'm passing in the dictionary that we're using that I showed you in the values file. And then the path is the path that I just created above, where we're going to put the simulated data. And as you remember before, in the user YAML, we defined the program name and the project name, so I'm just using that same program and project name here. All right, now that we're finished generating that data, we can continue on and run the submission order command. So I'll just paste that here. And this command will basically generate a submission order for the data based on that data dictionary we're passing in with the URL flag. Then we're also passing in this node name flag, which will tell the submission order command the node to generate the submission order for. And then lastly, this path command, which tells us where the generated data is. All right, now that that has completed, we are ready to submit data to our data commons. So I'm going to do that via the submitting data command. Here I'm just passing in the host of my data commons. I'm also passing in the project and program right here, and then the directory where that data was submitted. And then here we're passing in that access token we created originally. All right, and this will take a second to finish. Now that that's finished, we can head back over to our data commons and we can reload the page. We can see data now. All right, if you'd like to see this data in your database, we can hop back over to the terminal and we can run this export command here, which is essentially getting the Postgres password from our Gen3 PostgreSQL secret. Then we're going to run this kubectl run command, which will create a Postgres client pod using this image, and we're passing in that Postgres password. Here we can do -L, and we can see all of the different databases we have, and to connect, we just pass that -C, and then let's look at Sheepdog. And now we can look at all of the different tables here. And let's just take a look at the node project table. And we can see there's some data now within our database. Come to the Gen3 values.yaml and search for persistence. And here you can just copy this whole block and put it in your values.yaml and set enabled to true. All right, now we can move to the Workspace tab. If you get an error when clicking on the Workspace tab, please check on your values.yaml file and make sure that the test user has the Workspace policy assigned to it in your user YAML. If the page won't load, make sure that your hatchery pod is running before moving to these steps. But this tab is going to be used for launching notebooks to analyze and explore your data directly. It's powered by our hatchery service, so if you'd like to learn more about the hatchery service, please visit our hatchery repository. But you can see we have an example Jupyter notebook here, so to launch it, we're just going to click launch. And this can take a little bit of time for it to fully spin up. All right, now our workspace is now running. If you had issues and your notebook did not come up, make sure that you come over here and do a get namespaces. And it's going to be in this Jupyter Pods namespace. Just make sure to check out the logs here. All right, lastly, we're going to talk about the exploration page here. So this is mainly used to make it easy to quickly search and filter the data in your data commons. And it's able to do this by having the data in Elasticsearch. So if you visit our Helm charts, there's an ETL Helm chart here, and this will deploy a cron job that will extract the data from Postgres, transform it, and finally load it into Elasticsearch. This is done via our Tube service, so if you'd like to read more, you can visit our Tube repository here. But I'm just going to start out by clicking on the Exploration tab. You can see here we don't have any data loaded, so I'll visit our ETL documentation. So there's a couple of values here. You can set enabled to true. This is done by default, so if you want to disable it, you can set it to false. ES endpoint in this video we won't have to set, but when you deploy to production, you'll want to make sure to update this value. And lastly, the ETL mapping. So this is YAML that defines what tables to move and how the data will be organized in Elasticsearch. We don't need to edit this since the data we submitted with the data simulator will match the default ETL mapping. So what we can do here is run this kubectl create job from cron job. Since that cron job already exists, you can see it here. I'm just going to paste this in now. And I'll just look for that ETL job. So it looks like it's running, so we'll wait a second for this to finish. Our ETL completed successfully, but if there is any issues, make sure that when you're looking at your logs that you pass in -ctube, since we want to look at the tube container logs. But we have a successful run, so the next part I'm just going to go to my values.yaml and I'm going to enable guppy by just doing guppy enabled true. I'm going to save that and run a Helm install. All right, and we're going to get pods and just make sure guppy's running. All right, looks like it's running, so we can go back over to our data commons and just refresh the page. You can see we now have data. So this job will run on a cron schedule. If you want to change that schedule, you can do so by visiting the ETL values.yaml and setting the schedule variable.